Okay, so for today's lesson 4.5, take a look at the problem of the day. Let's factor the expression. Pause the video and you're ready to move on. So in 4.5, we're going to solve quadratic equations by finding square roots. So to give you a little bit of a square root review, first of all, we have two properties, the product and quotient property. How I would address the product property is if you have, actually I'm going to write it here, if you have square root of AB, A times B, all inside the root, we're allowed to factor them apart and make it square root of A times square root of B. So if you have a square root, you're allowed to split it up into its two parts. Quotient property, we would start off, quotient means division, obviously, right? So square root of A over B. You are allowed to split them up into their pieces. So square root of A over square root of B. So we're going to use these two sets of properties to actually simplify the expression. This is something that you've seen in Algebra 1 before. You spend a decent amount of time reviewing it. So if we look at square root of 80, I need to think to myself, okay, if I take all my perfect squares, all right, so you have 2 squared, which is 4, 3 squared, which is 9, and so on. I need to split up 80 into two factors, one being a perfect square. All right, so if I take a look at this, I know square root of 80 is square root of 16 times square root of 3. So you want to split it up into two parts, the first number being a perfect square. The reason why we want a perfect square is when I take the square root of 16, I get 4 square root of 3. That's my answer. So when you split them up, you want to take one number being a perfect square times something else. Now how do I know when I'm done? Always look at the square root again. Square root of 3. Square root of 3, what are my factors? 1 times 3. 1 and 3 are both not perfect squares, so I can't simplify further. So this uses the product property. In letter B, we're going to use the quotient property. Quotient property, let's start off by splitting them up into two parts. And what do you notice about these? 4 and 81 are both perfect squares, so this one's going to work out nice and neat. Square root of 4 is just 2. Remember, the root goes away when it's a perfect square. Square root of 81 is 9. So my answer is 2/9. Now, if I look at letter C, all right, so B used the quotient property, split them into its two parts. C is sort of like product property again, but if I take a look, let's see if we could split up 6 and 21. All right, what are my factors of 6? 6 times 1, 3 times 2. 6 is not a perfect square, neither is 1. 3 is not a perfect square, neither is 2. So I can't split 6 up. But take a look at 21. It's 7 times 3, 1 times 21, none of them are perfect squares. So in this case, what I actually have to do is take a step to multiply in them together. They are like terms, so I could multiply them. Now the number 126 I will split up. 126 is actually 9 times 14, which gives me 3 square root of 14. One of the numbers has to be a perfect square. But how do I know if I'm finished or not? All right, 14 is what? 1 times 14, neither are perfect squares. And I have 7 times 2. 7 is not a perfect square, neither is 2. So sometimes you could still split them up, but the only way you could actually split them up with square roots is if one's a perfect square. All right, so 2, rationalizing. Denominator is not a perfect square. Okay, if we go back to 1 for a minute, you see here, what was my denominator in letter B? Square root of 81, which simplifies to 9. In this example, you're going to see none of them have perfect square in the denominator. So how do we go about solving these? So let's use the quotient property to split them up. Two roots. Whatever's in the denominator, I multiply by top and bottom. when you multiply roots, you multiply like terms across. So square root of 5 times square root of 2, square root of 10. Square root of 2 times square root of 2, square root of 4. So I get square root of 10 over 2. We have to ask ourselves, is this my final answer? First of all, we rationalize it because if you take a look here, the denominator is now a whole number, which is 2, and that's what we wanted. That's why we rationalize. But also, if we take a look here, I cannot divide these two numbers because they're in like terms. Square root and not square root, so I can't divide them. Also, can I split up the square root of 10? What do I have? 5 times 2. 5 and 2 are not perfect squares. And the same with 1 and 10. So this is my answer. So let's try letter B. And you might want to pause the video to try it yourself first. So what do we get here? I'll talk about the workload. Square root of 24 over square root of 9. 24, always ask yourself, can you split it up further? Yes, square root of 4 times square root of 6. All right, and you get 2 root of 6 over 3. All right, now if you look at C and D, how are these different? These are different because if you notice, we have 2 terms in the denominator as opposed to 1. So when we rationalize the denominator, we're going to take the bottom, multiply by top and bottom, but we have to change the sign in the middle. So we see it's positive, now it's negative. Now we're going to distribute the 3 to both parts. Multiply like terms though, so be careful with that. Now 7 times 3 is 21, but be careful, 3 times negative root of 2, they're unlike terms. So the negative 3 goes in front with the root of 2, which is something you have to get used to. Now the bottom we do FOIL. But if you notice, it's like a difference of 2 squares where it's the same thing with opposite signs. So you could do just first and last of FOIL. So watch. First is 49. Minus. Last is negative square root of 4. Which will simplify here, right? What's it? 49 minus 2. So you get 21 minus 3 root of 2 over 47. That's my final answer. So the whole point, once again, rationalizing the denominator is that the root disappears in the denominator. And you see that also disappeared in the denominator for these as well. Remember, first and last of FOIL. Pause the video, try the next one, see what you get. And I'll continue. I'm actually going to just show you the work to it, so why don't you pause the video, try it first. All right, so check your work for letter D. You get 10 plus 5 root of 5 over negative 1. Be careful. You can also, if you wanted to simplify, if not, I'm okay with that because I know these are harder problems. You could divide them both by negative 1, which would mean change the signs up top. If you want to simplify, you could get negative 10 minus 5 root of 5. Honestly, if you left it as the boxed answer, that's okay as well because I know these are complicated. Now, the next part we're going to look at is how to solve quadratics. All right. we got to determine when you can use what we're talking about now or when you have to factor. So in this case, you can solve algebraically when there is only one variable. All right, so when there's one variable, so if we see here, we only have one variable, x squared. The other way you have to factor, you must factor when there are two variables. So if you look here, why we had to spend all that time on factoring and when we factored before is because there's two variables. You have to factor. It's not going to work where you can solve nice and neat. On this side, you only have one variable, so you could solve algebraically. That's what we're going to take a look at today. You know, we spent a lot of time in factoring. Sometimes, though, if you remember, there's some problems that we did with factoring that didn't work, that we said were unfactorable. So when can that happen? That could happen where maybe the answer is a square root. That's why we reviewed square roots and why we're learning to solve algebraically. That's why in quadratics we have to learn to solve them a few different ways, because not each method doesn't work for all of them. All right. So what if we got one that was unfactorable back when we were factoring? We'll take a look at solving here. Now when we solve, all right, we have x squared equals 144. We need to make sure it's isolated. What we do next is we take the square root to both sides. That's how you're going to do a square. So my answer, I'm going to type my answer here. X equals, actually, you know what? Let's just write it. X equals, now, one thing you have to get used to is we're going to write plus minus in front of our answer. You know that means a positive 12 and a negative 12. There's going to be two solutions to these. So mathematically, the shorthand is we just write the plus minus up front. All right, and that's how you solve it. Letter B. In order to get x by itself, we have to divide first, both sides by 3. So we get x squared equals 18. And take the square root of both sides to get x by itself. Don't forget you could split up 18, square root of 9, square root of 2. You get x equals plus minus 3 root of 2. All right, I'm going to pause the video. I want you to try to do C yourself and then check your work. All right, so take a look at the next one here. We had to add 3 to both sides, transpose the negative 3 over positive 3, so we get 3x squared equals 21. Divide both sides by 3, x squared equals 7. Take the square root of both sides, we get x equals plus minus root of 7. Final answer, remember we cannot split 7 up further. So we have two last examples today. And I make a note, don't forget order of operations in solving. It's the same as when you would solve algebraic equations. So I'm going to pause again. I want you to try them yourself and then see what you get. I think the common mistake I see a lot of times is that we forget the plus minus. So let's look at the next one. X squared over 25 minus 6 equals negative 2. We want to add 6 to both sides. How we get rid of a fraction is we multiply both sides by 25 to get it to cancel out. X squared equals 100. Take the square root, x equals plus minus 10. Take a minute, try the next one. We'll talk about it. Now in this case for the last one, we want to take a look at getting x plus 3 squared by itself. So I want to get rid of that 1/5. Do not distribute the 1/5. Do not square these. Do not distribute the square. There's a lot of things you can do wrong to make them more complicated. First things first, I have 1/5, so I want to multiply by the reciprocal, which is 5 over 1. So you get x plus 3 quantity squared equals 35. Do not FOIL. If you FOIL, you're going to have to factor, and you can't do that. Take the square root of both sides. X plus 3 equals plus minus root of 35. Positive 3 comes right in front as negative 3. Something you just have to get used to. So my answer is negative 3 plus minus root of 35, and there's no way I could break up 35. All right, that's it for today's lesson. So I want you to pause the video, do the problem of the day, and examples 2 and 3, and we'll pick back up tomorrow.